Alright guys, in this video I'm going to be talking about graphing polynomial functions. So before we start graphing, what we need to do first is make sure we understand the key features of a polynomial function. So there's going to be three that we're going to talk about. The first thing is going to be the form it's written, and that's going to be standard. So standard form shows the terms by degree in descending order descending numerical order, numerical order. Okay, the next thing that's going to be really important is going to be the degree of a polynomial. You'll be using that word a lot. So the degree of a polynomial is the greatest degree and when I say the word degree, I'm talking about the exponent. So the greatest degree of any of the terms. Is going to be the degree of the polynomial. And then finally, the leading coefficient. So the leading coefficient is the coefficient of the term with the highest degree. So here are the three things. We got standard form, that's going to be how it's written, and it should be in descending numerical order. If we don't give it to you in that order, you should be rearranging it. Then the degree of the polynomial is going to be the highest exponent, and that's what we refer to it as. And then the leading coefficient is the coefficient of the term with the highest degree. So let's do an example. Example 1 is going to be rewrite in standard form. And determine the degree leading coefficient and number of terms. So here's our equation, 2x minus 3x to the fourth plus 6 minus 5x cubed. So as you can see, this is not in descending order as far as degree goes. So what we need to do first is rearrange it. So which one has the highest degree? That's going to be the negative 3x to the fourth. So we need to rewrite that first. And then we go descending order. So we'll do minus 5x cubed. There's no x squared, so we jump to plus 2x and plus 6. So all we're doing is using the commutative property of addition to say we can move everything around. Now that's now that it's in order, this is in standard form. So now I want to know what is the degree. So the degree of this, remember if we go back, is going to be the greatest degree or the greatest exponent. So here that's going to be a 4, which means that this is a 4th degree polynomial. The leading coefficient that's going to be the coefficient of the highest degree, so that's going to be the -3. And then how many terms are there? So each thing being added together is a term. So we have 1, 2, 3, 4 terms. And that's it. The thing to be careful about with number of terms, you need to make sure that this is completely simplified. So if I had, like, say in the original equation, we also had like minus x, we would have to combine the minus x and the 2x to be just x. Okay. Alright, so now we need to make sure we understand end behavior of a polynomial. So end behavior is exactly what you would think. It's the end, like it's how the graph is behaving at the ends. So if we have a coordinate plane and we have some sort of polynomial, like what is happening at the end of the graphs. So there are a couple things you need to take note of first. So the end behavior describes what happens to the function, value as x approaches positive and negative infinity, which is exactly what I just went over, right? So if we have a graph, as we approach positive infinity, what's happening? Oh, it's going to infinity. As we approach negative infinity, what's happening? Oh, it's going down to negative infinity, or at least the graph that I just drew. All right, there are going to be 4 types. And they depend on the degree and leading coefficient. Okay, so first type we're going to talk about is going to be if you have an odd degree. So when I say odd degree, one thing you should be thinking about is your odd numbers, so 1, 3, 5, 7, etc. But one thing I would hope that some of you guys are thinking about is the cubic, right? So x cubed, the graph looks like this. Okay, so odd degree is going to go in opposite directions, like down, up. If it's positive, well, if the leading coefficient is positive, so if we have an odd degree in the positive leading coefficient, then that means our graph is going to have an end behavior of down, up. So as x approaches positive infinity, it's going up, and as x approaches negative infinity, it's going down. The next thing that could happen is if we have an odd degree. But let's say our leading coefficient is negative. So if we have an odd degree, we know that that means it's going to go in opposite directions. Negative leading coefficient means our graph is going to change directions. Remember, a negative leading coefficient, if you go, actually go back to the last example, the leading coefficient, that is what's going to show us like if there's any reflections. So if there's a reflection, it's going to go the opposite direction. So it'll be going up, then down. Poorly drawn. Okay, so up, down. Okay, so if we don't have an odd degree, the next kind of degree we can have is an even degree. Even degree is 2, 4, 6, 8. When I say even, the lowest one you should be thinking about is x squared, and we all know that that graph is a beautiful parabola. So if we have an even degree and a positive leading coefficient, then our graph will have an end behavior of up, up. Now notice real quick that I haven't been connecting any of these because we don't know how many turning points there's going to be. It depends on what degree our polynomial is. But if it's even, regardless, and it's positive, we'll start on the left with it going up and we'll end on the right with it going up. And then the last kind is going to be an even degree and negative leading coefficient. So if it's even, it's going to be going in the same direction, so either up, up, or if it's negative, they're going to be going down, down, the end behavior. Okay, so even, think same direction, think of your quadratic. If the leading coefficient is positive, we end going up. If it's negative, we end going down. Odd degree, you should be thinking opposite direction. If it's positive, we end going up towards positives. And if it's negative, we end going down. It's kind of a way to help you remember it.